This is chapter 11. The objectives for this chapter is to identify the types of prints that an electrician may read, list the standard parts of a drawing, recognize and use the standard electrical symbols, understand the schedules that are found on prints, describe the two types of notes, read an electrical print, recognize specifications and understand their importance, draw circuit layout on a floor plan, and plan and install electrical components including 3-way and 4-way switches according to circuit layouts. Some of the technical terms encountered in this chapter are drawing, electrical prints, electrical schedules, foundation print, framing print, general notes, home run, legend, local notes, plot print, plumbing print, print, revision block, scale, specifications, and title block. Any successful project starts with a plan. An electrician's plan may include prints, schedules, and specifications to show the type and location of all devices, panels, and wiring. There are specific symbols and terminology on these plans that the electrician must know to correctly install the proper products. Prints. A print is a copy of a drawing that illustrates the materials, locations, and methods that must be used during construction. Prints may be called drawings, plans, or blueprints, a term that was popular when the printmaking process created white lines on a blue background. For clarity, a drawing in this text will refer to the original document that is created, revised, and approved. A print is a copy of the drawing. Each group of workers of a project will receive a set of prints that were made specifically for that group. The excavators use a plot print when shaping the land. The masons use a foundation print to locate the concrete and bricks. The plumbers have a plumbing print to locate fixtures and piping, and the carpenters have a framing print to locate walls. And the electricians have an electrical print to locate devices and calculate circuits. Each group needs access to all the prints so everyone understands where the group's materials will be installed. Plot prints. Plot prints will show the major land-based features such as a swimming pool or garage. Often this print describes the slope of the land. When appropriate, plot prints will also designate property lines, fences, and easements. Electricians use an accurate and scalable plot print to locate the service cables, panel, and meter outside of the house. The amount of cable required for a service can be accurately calculated and ordered if the plot print is accurate. The items and features described in a plot print often control the location of the underground wiring. The local AHJ or authority having jurisdiction will be able to tell you if these items and features can be traversed when running the service cable. The foundation prints show the location and construction of the foundation walls and footings and other parts of the house that require concrete. The footings and foundation walls support the entire house. Features such as fireplaces, patios, and driveways may also appear on the foundation print. In situations where service cables may have to pass through a poured concrete block or wall, the foundation print will show the mason and the electrician where this will occur. A length of conduit can then be placed in the concrete wall before they pour to create the hole. Otherwise, the hole will need to be drilled after the concrete sets. Any cables that will be located under a driveway should pass through conduit The drive wheel will not need to be removed if the cables are replaced. Plumbing prints. A plumbing print contains the locations of all fixtures and toilets, sinks, showers, tubs, water heaters, and anything else that is connected to the water supply or the sewage lines. The location of the piping that connects these items may be shown on the drawing, but not in most residential projects. You may be able to determine the most likely routes for the piping by looking at the locations of the fixtures and the structure around them. A better method is to contact the plumber and ask about the probable routes of the piping. At first, this may seem to be a type of print that an electrician would not have to review. After all, water and electricity are supposed to be separated at all times. Actually, it is a good reason to have a plumbing print. It is easier to avoid the plumbing lines and fixtures when you know where they all are to be installed. Another reason to review the plumbing print is to locate electrical devices for items such as hot tubs, water heaters, washing machines, and even yard sprinklers. Framing prints. Framing prints. There are usually many framing prints in a set of construction project. In a set for a construction project, these prints will illustrate features from the overall shape of the house to the small details of trimming out a window. The beams, joists, and other supporting features of the house will be dimensioned on the framing print. Carpenters also use a floor plan to locate walls, doorways, stairs, and windows. These structural details will help you determine where to run the cable and conduit in a manner that reduces the number of holes in the joists. Drilling these holes takes time, and the holes may reduce the strength of the joists. The floor plan is a useful print when you must locate outlet receptacles and switches within the rules of the NEC. Electrical prints, symbols that represent lighting fixtures, outlet receptacles, switches, panels, and the circuits that connect them are shown on an electrical print. The general location of this equipment is shown, but the exact position may not be dimensioned. The electrical print should contain details that describe the types of equipment that you are required to install. You must be able to understand the symbols, dimensions, notes, and lists on an electrical print in order to complete the job accurately and within all relative codes. The electrical print is used to order the equipment, determine the length of the cables and wires needed, and inform the local inspector about the proposed layout. Since this print is usually created directly from the floor plan, you can foresee most of the structure and adjust the cable and conduit routing. Understanding electrical prints. To many people, an electrical print may look like a drawing that someone covered with hieroglyphics and curved lines. You will soon see the circuits, devices, and wiring that are represented in a well-made electrical print. Basic print components. Before focusing on the specifics of a print, there are some basic components that you will need to understand. These components are present in all drawings and should be easily recognized. The style, size, and even location of the components will vary on drawings created by different schools and companies. However, the information in each must be understandable and complete. Title blocks. The title block in the area on a print that contains basic information for identification purposes. Again, the title block is the area on a print that contains basic information for identification purposes. You will find items in the title block such as the drawing name, names of people who worked on the original drawing, drawing number, and drawing scale. And this is the first place to look to verify that you have the correct drawing for the job. See figure 11-2. 1. Revision blocks. A drawing may require corrections or changes throughout its lifetime. A revision block is an area on a drawing where the changes and corrections are recorded. There may be lettered or numbered symbols next to each revision in the revision block. Look for a similar symbol on the drawing area to find the related revision. The revision block is a good place to look if the print appears to be different from the way it did when the job was first started. For this, see figure 11-2, top of the screen. Print sizes. The print must be large enough to be legible, yet small enough to handle on the worksite. Standard sizes are shown in figure 11-3, bottom of the screen. Most electrical prints are C size, D size, or E size. Also notice the proper way to fold a print to a manageable size. You will have to do this if the print is not rolled up. Scale. The scale of a drawing is the ratio of the size of the object to the size that the object was reduced or enlarged in the drawing. A simple example of a 30 foot by 40 foot house that measures 7.5 inches by 10 inches on a drawing. A simple example is a 30 foot by 40 foot house that measures 7.5 inches by 10 inches on a drawing. The scale is 1/4 of an inch equals to 1 foot. So every 1/4 inch measured on the drawing equals to 1 foot. This means that the drawing is 1/48 the size of the actual house. If a wall drawn on this print measures 3 3/4 inches, and you know that the NEC requires no point on a wall to be more than 6 feet away from a receptacle, you can calculate that there should be at least 2 receptacles on this wall. For this, see figure 11-4. The scale is 1/4 inch to equals 1 foot, or 1/48. The wall measured on the drawing is 3 3/4 inches. The actual wall length is 3 3/4 inches times 48, which is equal to 180 inches or 15 feet. Symbols. Most symbols used on electrical plans have been approved by the American National Standards Institute, ANSI. These should be understood by every electrician and committed to memory. A misunderstood symbol may cause the installation of an incorrect device. Not only does this make extra work, this mistake can create an unsafe installation. Figure 11-5 shows the commonly used symbols you will need to remember. The section at the end of this chapter will illustrate these symbols and the types of devices and circuits they represent. Other less common symbols may be used if they are defined in a legend. A legend is a part of the print, plan, or specifications that defines each symbol. Normally, a small letter, A, B, C, or D, will accompany a special or unusual symbol. See figure 11-6. Lines. Circuits are represented by curved lines drawn from one device to another. The lines are curved to prevent any confusion with the architectural lines. Most of these lines will be solid, the designation for wires that are concealed in a ceiling or wall. Again, the lines are curved to prevent any confusion with the architectural lines. Most of these lines will be solids, the designation for wires that are concealed in a ceiling or wall. Again, they must be solid. Circuit lines made from long dashes represent wiring that is concealed in a floor, and short dashes represent exposed wiring. Any device or any service or feed runs, again, any service or feed runs should be indicated with a heavy line. See figure 11-7. In every circuits were drawn If every circuit were drawn and installed as installed, the lines would continue to the circuit breaker panel. Again, if every circuit were drawn as installed, the lines would continue to the circuit breaker panel. To prevent this buildup of lines near the panel, the circuit line is not drawn all the way back to the panel. Instead, the circuit line stops at the point where the run back to the panel begins. This is called the home run. The branch circuit's home run to the panel is then identified with an arrow. There is one arrowhead for each circuit in that run. Often the circuit is labeled with a number for clarity. See figure 11-8. Notice the hash marks that cut across the circuit lines. These indicate the number of wires required. The long hash marks indicate the ungrounded wires, and the short hash marks indicate the grounded wires. Schedules. Electrical schedules are tables that list items such as fixtures, power requirements, panel board information, receptacles, and switches. See figure 11-9. Schedules save print reading time by placing information in one easy to find location. This helps with project estimation, purchasing, and construction. The following are some examples of schedules. Lighting and fixture schedule. This type of schedule lists the lighting fixtures used in the project. Each row in the schedule lists basic information for a single type of fixture. The information typically includes the number of fixtures required, the manufacturer, model number, and number and type of lamps. Each type of lighting fixture also has a unique mark, normally identified as a letter. The marks, which are included on the lighting plan, identify the location of the fixtures. Equipment schedule. An equipment schedule lists the large electrical equipment being installed. The information provided in this schedule varies depending on the specific type of equipment listed. Equipment schedules may include the voltage provided to the equipment, size and type of overcurrent protection, and the number and sizes of conductors feeding the equipment. Motors, heating units, and cooling units are often listed in the equipment schedules. Panel schedule. A panel schedule lists the basic characteristics of a lighting or power panel. The information normally includes the panel voltage, the panel amperage rating, and a chart listing the circuit breakers, and equipment served by each circuit. Miscellaneous schedules. The number and size of schedules is a good way to determine the size of the project. For large projects, schedules may be included to aid estimating and purchasing. A receptacle schedule and switch schedule may be included. These schedules are similar to a lighting fixture schedule. Notes. Often there will be information that is too difficult or confusing to describe with a dimension or symbol. That is when a note should be added to the drawing. General notes, those that contain information regarding the entire installation, should be grouped together at the bottom or side of the drawing. Notes that cover a specific location are called local notes and may be moved to the area of the drawing that is under control. See figure 11-10. A pro tip before seeing that figure is using the print as a checklist. During the rough-in process, it is common to use the floor plan as a record of work completed. When a run has been completed, a highlighted or colored pencil may be drawn over the run on the floor plan. This practice prevents runs from being overlooked. When two or more electricians are working on the same job, this process is necessary to keep track of work completed. And here's a look at figure 11-10. Most drawings will have general and local notes to clarify various issues. Specifications. Specifications are documents that list the items of a schedule. The local code requirements not found in the NEC, and designations of those responsible for supplying the materials. Specifications or specs are included with the prints to clearly define what is to be done, how is it to be done, or how it is to be done, and who is responsible for doing it. Although the prints have lists of materials to be purchased, the specifications will also have a similar list. If the lists do not match, the specifications are typically followed. This is because a print may be used for multiple projects, but the specifications are the documents that are created for a specific project. Often the local building commission or the other AHJ or authority having jurisdiction uses the NEC as a starting point and adds or modifies some rules. To make sure the electrician and the homeowner are aware of these changes, these specific rules are usually listed in the specifications. To avoid confusion and lost time, the specifications stipulate who is responsible for purchasing the materials. Most installations require the electrician's company to purchase all of the materials, but some installations may not be so clearly defined. For example, if one company is installing the electrical wiring and another is installing the phone and network cabling, which company purchases the multifunction box where both systems terminate? Specifications should be thorough and clear so that everyone involved is completely informed. Wiring circuits. We will now look at the actual wiring of circuits by comparing print and pictorial drawings. These types of drawings cover common circuits found in residential construction. Compare the circuit in each print with the pictorial. Metallic conduit, flexible metallic conduit, and non-metallic cable will be drawn as shown in figure 11-11 on top. As you study the circuits shown in figures 11-12 through 11-27, note the wiring method. Trace the different wires in the pictured drawings until you become familiar with the symbols in the circuit layouts. No grounding wire is shown in pictorial drawings for metallic conduit. None is required. The conduit itself serves as a grounding conductor. Prints do not show the grounding conductor regardless of the wiring method used. Figure 11-12, junction boxes serve the purpose of dividing a circuit into several directions. Study the circuit layouts and the schematic and compare them with the actual wiring method shown in the pictorial drawing. Figure 11-13, a simple pull chain fixture at the end of a circuit run. The switch is the fixture itself. Figure 11-14, a single light controlled by a wall switch. The feed is to switch. The switch never interrupts the neutral conductor. Figure 11-15, a continuously live duplex grounding type receptacle. Both parts of the duplex are served by the circuit wires. (11-16) Top, a switched duplex grounding type receptacles are used in rooms where overhead lighting is not desired. One or both sides of receptacle are controlled by the switch. 11-17 Bottom, light controlled by a single pole switch has outlets beyond it that are always live. Source or feed is to switch. (11-18) Top, two single pole switches on the same circuit. Each switch controls a different light. 11-19 Bottom, switch receptacle combination. The switch controls lights while the receptacle is always live. A single circuit supplies both the switch and the receptacle outlet. 11-20 Top, split wired receptacles. The top half is always hot. The bottom half is controlled by a single pole switch. 11-21 Bottom, light is controlled by a switch. Receptacle beyond the switch is alive. The source is at the light. (11-22) Several light fixtures are controlled simultaneously by a pair of three-way switches. 11-23 A pair of three-way switches controlling a single light fixture. The source is to one of the three-way switches. 11-24 A light fixture controlled from 4 locations using 2 three-way and 2 four-way switches. 11-25 One light controlled by a single pole switch. One circuit is the source. The single pole and three-way switch are housed together. 11-26 Top, single pole switch controlling a remote lighting fixture. Again, single pole switch controlling a remote lighting fixture which cannot be seen from the switch location. The pilot light is on when the fixture is on. There are also switches available with red handles that light up when the switch is on. The source is at switch. There are different methods of wiring such a switch. Refer to the manufacturer's instruction. Figure 11-27 on the bottom. 3 switches on one circuit. Each controls a separate lighting fixture. The switches are all at one location in a multi-gang box. The source is at the switch. And moving on to the review questions for the chapter 11. First, indicate the meaning of each of the following electrical symbols. And as you can see, they are labeled single receptacle, a light fixture, a duplex receptacle, a duplex GFCI receptacle, a special receptacle or special purpose receptacle. Then we have a switch. Then we have a four-way switch. Then we have a surface mounted fluorescent fixture. Question 2. If you see a standard symbol used in an electrical plan with a small letter alongside it, where would you look for an explanation of its meaning? That would be on the print's legend. 3. An electrical plan that shows the size and number of conductors in cable runs is known as an or a, and that is an equipment schedule. Number 4, explain the value of an electrical plan during a rough-in. It saves extra work and time during the installation of electrical equipment and wiring. It saves money in the purchase of materials for any project by specifying the accuracy of what is to be used. It prevents double work or overlooked work or missed work. In this section, create sketches for the following installations as you would when drawing on a floor plan. Include the proper symbols and lines. Number 5, a single pole switch controlling 3 light fixtures. And you can see the sketch and the symbol on the right hand side, lower right. Number 6, draw a single pole switch controlling a light fixture with 2 receptacles always live on the same circuits. And as you can see, this is drawn on the right lower side again. Number 7, a pair of 3-way switches controlling a light fixture. And the drawing is pointed at by the question number 7, lower right again. Number 8, on a separate sheet, draw and complete the following diagram. And you can see the completed drawing, which has 3-way switches and a light bulb or a load with a source with neutral and hot. Moving on to the Know the Code section. Number 1, section 90.8a states that plans and specifications that provide ample space in raceways, spare raceways, and addition spaces allow for, the answer is, future increases in electric power and communication circuits. Again, that is in section 90.8a, that is in the beginning, towards the beginning section of the NEC, in this case the 2011. Number 2, which units of measurement appear first throughout the NEC, metric or US customary? And that would be US customary, and they are probably most likely talking about distances, basically distance measurements, amount, weights, anything that is basically a distance or a perimeter or an area is given in feet, which is a US customary. Number 3, according to section 210.70 A1, which rooms require at least one wall switch controlled lighting outlets? And that would be every habitable room and bathrooms. And that concludes chapter 11. This chapter has been electrical prints and specifications. Thank you for listening and continue your studies. Good luck.